I think we're live now. Uh, Morning, guys. It's 11 a.m. right now. I was thinking of doing another deep dive into uh, the concurrency book that I was studying. We had reached a section in benchmarking where I was learning how to use the Timeit module and a few other ways of profiling, memory profiling slash time profiling your code. It seemed very boring to me. That's probably the reason like I had a bit of a block while studying it. I didn't really understand the point of studying it right now in my journey because there's a good chance I'm not going to have to use it for some while. But yeah, the author insists that it is necessary for every developer to understand what all that is about, even though you don't use it. So I'll just power through. That's why I actually set up this live. I was hoping to study by myself today, but I thought it would be best if I just do it in public and don't lose motivation. So yeah, what I'm going to be doing is just running a 45-minute timer for the same. Right. इसके बाद what I can think of doing is, let me get my terminal also here. All right. Automator load session. Perfect.
In this video, we're going to be
I had this video on the Timeit module, so I'll just finish it and we can pick from there. Let me just get my charger in order. Alright, I'm back. Let's get cursor on. Cursor, concurrency. Again, just to reiterate, I store my code in a Jupyter notebook for uh, learning purposes. Enjoy discounted usage through. Okay, great. I don't think I can use it though. I'm on the free plan. The free plan genuinely sucks on Cursor now. Like, I'm almost considering switching over somewhere else. Yeah, maybe I'm done with VS Code or something like that. Maybe you could move somewhere else. I was thinking actually ki, like in the long run, I'll try to get used to NeoVim. I really like the idea of working in that complete no distraction environment. That seemed very productive to me and really cool, to be honest. So I was thinking of switching to that, but यार काफ़ी overhead होगा उसमें, you know. So it's not something I can take up right now when I have so much to do. Yeah. So I try to get used to using the terminal like on a daily basis for everything that I do. But yeah, studying NeoVim and studying BI before that is going to be quite an overhead. I'll have to relearn a lot of things for that. But कोई ना करेंगे बाद में. I'll start with the Timeit module wala code. I had covered some of it, right? This first note says Timeit is strictly for smaller code snippets, which is true. Usually a single function call usually. To benchmark an entire script or something big, use a profile module instead. Profile module अभी तक cover नहीं किया मैंने. The Timeit module by default turns off garbage collection. I have no idea how garbage collection works, so this concept is a little alien to me. If your test code is dependent on garbage collection, then you have to manually turn it on in the setup code. You have to manually turn it on in the setup code. Cool, makes sense. Okay, let's start.
Exploring how we can use the Timeit module to time small snippets, produce some
Covered most of this.
than random to find out which see exactly whether it's faster or not. And another thing I want to mention is that when you are using Timeit, it temporarily turns off garbage collection, which can make independent timings more comparable. But garbage collection
Forgot to set my timer. Wait a second.
Can also play an essential part in your timings, so you're going to have to look into that, whether your code is actually being timed correctly without garbage collection enabled. And our next example is going to be using functions that require a bit more setup, such as if you have some variables that you need to pass in as arguments. And one example is going to be this function here that generates a list of random numbers. What if we want to pass in an amount? And I'm going to be using a list for this. And I'm actually getting some syntax highlighting because this does return to us a list of float. So I'm just going to change that real quick. This will be float and this will be float. And what I'm going to be comparing here is whether it's faster to use a list comprehension or to just use a normal for loop. So I'm going to go right under this function and define the same thing in its list comprehension form. And we need to change this to float as well. I don't know what I was doing there. Anyway, right now we have two functions that we can actually test because I called them here and here. And if we run that, we're not going to get anything because it returns numbers, but right now we right under this function and define the same thing in its list comprehension form. And we need to change this to float as well. I don't know what I was doing there. Anyway, right now we have two functions that we can actually test because I called them here and here. And if we run that, we're not going to get anything because it returns numbers, but it doesn't print anything. And that's my fault because I wrote this all in Jupyter Notebook. So we will print those two. And what we should get back are two lists that contain 5 random numbers each. Anyway, that's what we're generating. Let's see which one is faster and how we can time it. And I'm going to remove these print statements. So down here, we're going to define the amount to be of type int, and that's going to be equal to 20. And that's what we want to pass in to each one of these. And it's true that it does shadow these, so I'm just going to quickly change this to amount n for amount numbers, I don't know. And first of all, we're going to go down here and we're going to create something called list time, which will be of type float, and that's going to equal timeit.timeit. And the statement is going to be our function call. So I'm just going to copy this up here and paste it in as a string. Since you can't directly call it inside here, it's not going to allow you to do that, or it's just not going to function correctly. We're going to have to pass it in as a string. And instead of saying amount of type integer, we're going to say that the amount is equal to the amount number. And we can even print that. So list time, and if we run this, we're going to get this error here, that this was never closed, and that's absolutely true. But if we run it again, we're also going to get that list generate random is not defined, which is quite annoying because we need to import list generate random. And even when we do that, we also need to create amount n because once again, this is isolated from our script. So it has no information about amount n or about our function. So one solution to this is to use globals. And here we can define the globals to be our globals. So now it's going to be able to see that we have this function defined and that we have the amount defined. And this time, when we run it, it's actually going to be able to give us the time back as a float. But of course, let's do it for both of them. So list time.
I'm assuming you ran it a million times on default, right?
and comp time, and it's the same thing, we're still referring to our globals so it can see everything inside our script. Then I'm just going to format the result nicely, so print and print.
Correct. Let's just carry it somewhere else. Let's generate random state. Oh, sorry.
Amount of type integer, we're
नहीं डाल सकते क्या? Why is that? Let's generate a random. Still a list. It's the issue.
We're going to say that the amount is equal to the amount number. And we can even print that. So list time, and if we run this, we're going to get this error here, that this was not generate random, or about our function find, and that we have the amount defined. And this time, when we run it, it's actually going to be able to give us the time back as a float. But of course, let's do it for both of them. So list time and comp time, and it's the same thing. We're still referring to our globals. So
.64.68. Comp time's a little faster.
it can see everything inside our script. Then I'm just going to format the result nicely. So print and print. So we will get the list time and the list comprehension time back respectively. Now, if we run this, we should see that amount is not defined because I did that silly thing earlier to change this to amount n, and I did not do that for this one. I'm still getting used to trying to use Jupyter Notebook to take notes when I'm teaching the videos, so I will keep this in mind for the next video, that if I change anything, I need to remember that I'm doing it also in my script. Anyway, let's run this, and this time we should get back both of the times that it took to run these functions 1 million times. And in this case, the list comprehension wasn't really that much faster. But it is worth mentioning that if you were to change to a different Python version, such as 3.10, you might get different results. In this example, it was considerably faster. So when you time your code, there's a lot of factors to keep into account. I'm not going to dive into all of that in this video, but I just want to show you how Timeit works because it is pretty cool for timing small snippets of code. But always check which Python version you're using, and if you change anything, always test again, because Python 3.11 took away a lot of the optimizations that we had in Python 3.10. Now they're just built into Python, which means
I think I'm at 3.13. Yeah.
the difference between using a for loop and a list comprehension in 3.11 might be completely irrelevant. But moving on to the next part of this video, and that's how we can repeat this test several times. Because right now we ran it 1 million times, but what if we want to do that 5 times? Well, we can do this in a for loop, but there's a much more convenient way of doing that. And I'm just going to remove every million times, but what if we want to do that 5 times? Well, we can do this in a for loop, but there's a much more convenient way of doing that. And I'm just going to remove everything besides the imports. And here I'm going to create a variable called random integer times. And that's going to be of type list of float. Because what we're going to use is going to return to us a list of the fastest times. So here we need to type in timeit.repeat. As you can see, we have something that's built into the Timeit module that allows us to repeat the test. And the statement is going to be equal to random.randint from the range of 0 to 1. The setup is going to be set to import random. And I clicked on something I shouldn't have. And then we can define how many times we want to repeat this test, and I'm going to set that to 5, which I believe is also the default. So now we can print random times, or random int times.
I miss autocorrect यार from cursor. It's not worth paying $20 for though. I thought free में तो चल जाएगा यार. मतलब क्या ही करते हो तुम लोग? So fucking stupid, man. Repeat. Let's see if it just works like this. Print comp time list. Comp time list. Let's see if that works. Okay. Time entered. Repeat. 6, 5. Why is comp time faster now? What the fuck? comp time ही बुलाया ना मैंने. Why the difference in time? That's odd. This is turning out to be.
And what we will get back is that I didn't close this again because I'm so used to the code editor helping me out with closing parentheses that when I do this in a string, I keep on forgetting. But this time, if we run it, we should get 5 times back. And it's usually a good idea to use repeat because sometimes your computer is going to be using a lot of resources to do something, so the times aren't always going to be consistent. But using repeat can help minimize the risk of your code being timed during some inconvenient time for your computer. Anyway, now we got those 5 times back, so let's do the same thing for the random times. And I'm just going to create it immediately below. And it's going to do the exact same thing, except it's going to use the random method, which at this point we know is much faster. But now let's display the results and find out which one is faster. So I'm going to use my print statements once again, and I'm rounding them to 4 decimal places, but this time you should note that I'm using the min method, which is provided by Python, and that's going to give us back the minimum. And the documentation recommends we use the minimum, because that essentially tells us how fast our computer is capable of running this snippet of code. And I'm just going to edit in that documentation right here, so pause the video if you're curious about learning more regarding that, otherwise I'm just going to run the program. So if we run this, we're going to get 2 times back, except this time I would consider it more consistent, since we actually ran the test 5 million times. And if we run this again, we should get similar results. As you can see, they are much more consistent than when we ran it one time. And finally, I just want to mention one more thing, and that is that if you have a function that doesn't really take any parameters, such as this calculate function here, it's quite easy to time. All you have to do is pass in that function without the parameters, of course, and that will give you back the time. So if we do this, as you can see, the only thing I passed into the statement was calculate, and nothing else. We didn't have to import globals, or we didn't have to do any setup, because this is a perfect reference to everything that we have in the script. And if we run that, it's going to give us the time back as well. So that's another way to do it that might be even more simple. It's just to create a wrapper or a function that you actually want to time your snippets of code inside. So instead of using setup and globals, here you can say random int implementation, and you can just do it here. Random int, I will say 0 to 1. Then we can just remove this line of code here and pass in the random int implementation. And if we run this, we should get the time that it took to run that 1 million times.
Yeah, exactly. You're not exactly testing that code.
Anyways, that's actually all I wanted to cover in today's lesson. Do let me know what you think about the Timeit module, whether you use it or whether there's something else you use to time small snippets.
Okay, I get your point. It's good. fine. This is nice. This was good. This was very good. The time it module. Command line मार चुका मैं नहीं कर रहा हूँ. Just get lost. Okay, yeah. Utilizing decorators. Okay. Start time is equal to timer dot default timer. Timeit dot default timer. I didn't get this to. Huh? Okay. Cloudy. Let's call it cloudy. Let's go with haiku. Can you explain this snippet of code to me? Def time this defines times. Okay. Okay. Which accepts a function as input. Def function timer args quarks creates a wrapper function that will replace the original function. It will accept any arguments to pass along with stupid रे मतलब थोड़ा थोड़ा नहीं आता मेरे को बस start time records the time before executing function value is equal to calls the original function with its arguments and stores the result. Okay, return value basically. Why should I return the value? Returns the original function's result so that the decorator is transparent to the caller. Runtime is equal to whatever return value, return the original function result so the decorator is transparent to the caller. So the decorator is transparent to the caller. This is example type is my function. Is syntactic sugar for my function equals let's time this function. I see, that's good. If I were to static write the if I were to type in that func argument, what would it be? So callable, a function that accepts any arguments, and return type t. tells you that the return type is preserved through the decorator. When you see in appear both the call it. Why the statement example of how I would access the positional slash works function definition. Oh, are you not done? Mm, okay, I got the point. अरे यार. This is a little more, I would say, flexible because the stuff that you're timing need not be a single function call. It can be a series of statements which might include function calls inside of them. So ये थोड़ा और flexible हो सक मतलब है. Timing context managers. Class that acts as a context manager for whatever code that you want to time. This is a little more flexible and non-invasive because you can time arbitrary sections of code. The code that you're timing need not be single function, as is the case with timing decorators. Not bad, this is nice, I like this. Oh, default. Why the fuck is this so hot, man? Can't imagine a MacBook is getting hot. Let's see activity monitor. चलो आपको भी दिखाता हूँ मेरा activity monitor. I hope that won't be a hazard. Okay, never mind, I'm not showing it. Slack helper. Why the fuck do I have Slack helper on right now? Screw this. WhatsApp. Screw it. Get lost. Okay, now we are better. I want to say good. Yeah, quit shit, Ray. I don't like that you have to quit apps, in this thing. Postman होगा कहीं पे तो या Postman. Finder ठीक है, Finder तो ठीक है. OBS Studio. The rest is kinda needed. Poor guy, man. Yeah, I think. Yeah, that makes things better, right? No. Yes. एंटर में ये करना है, एग्जिट में और कुछ तो करना है. if self dot verbose, I'm assuming is here only. If self dot verbose print, I think we are good. We are counting milliseconds over here. ठीक है, I mean fine. Big deal. We define a timer class which features a constructor init, तेरा init, तेरा entry point, enter पे क्या करना है, default timer start हो रहा है basically. तू Timeit use कर रहा है, okay, cool, fine, not a big deal. And an entry point. I think Timeit is like required, no? I don't have a requirements.txt. Why am I living in the Stone Age, right? Pip show Timeit. Pip list. By how do you get Timeit? Ah, it's in Python. That's what it means, right? AI agent? Huh? Fuck, I think I got it in the wrong place, right? Pip install Timeit. Why am I so bad at this? Freeze. अभी क्या कर लो? This shit's gonna give me a heart attack, right? Alright, I'll stop for now. Not really a lot of progress done. But नहीं हो जाएगा. Profiling वगैरह बचा है. Improve all that nonsense. Memory profiling. Profiles. हो जाएगा. कर लेंगे. देख घुमा के. Okay, I'll stop streaming, okay?